Okay, we're going to start looking at Chapter 12, and we are going to deal with what are called transformations. Now, a transformation is, let's say that you have an image, okay, and all these things. You have some nice animations here. If you have some sort of image, such as a pentagon, a parallelogram, a set of points right here, we can transform them in a certain way where we won't change the nature of the shape, at least here in the beginning in these first few sections. So a pentagon will still be a pentagon and all that, but we will reorient its position in space, or in this case in a plane, in a two-dimensional plane. We will reorient how it looks. Maybe we'll shift it around, maybe we'll rotate it, maybe we'll flip it, something like that. So here are three terms here that you might want to look at and focus on. This is what 12.1 focuses on, its reflections. 12.2 looks at translations, and 12.3 looks at rotations. Okay, so if you pause the video at some point, you can read these objectives or things that we're going to go over. That's the good thing that we can do with videos. Okay, so I'm going to quickly look at reflections here first. Now, here's an example of one. A reflection's like a mirror image. Okay, so I'm looking at myself here, and I see that I'm kind of looking at a mirror, okay, like this, for instance. I'm looking at myself, and here's my flipped image of me. And here's an example of what you'll really be looking at on a graph. If I have, for instance, like this quadrilateral right here, and I have these four specific points we can look at, these vertexes right here. Let's call this one A, for instance. I'm looking at A. Here's A's mirror image. I'm going to go ahead and call it A prime. Okay. And I could do the same thing here. I call it B, B prime, C, C prime, D, D prime, etc. I could call one Optimus and call one here Optimus prime. Okay. So this right here, this is called the axis, like y-axis, for instance. Think of this like y-axis. This is called the axis of symmetry. I don't know what the heck that thing's doing. Whoa. Okay. So the axis of symmetry. So what that basically means is that I have a symmetrical figure. Whoa. I have a symmetrical figure. And symmetrical just basically means mirror image, something that's flipped across an axis. So if I look at point A here, this is the exact same distance away from this axis as A prime is. Let's say this was 6 units away. 6 units from here, 6 units from here, etc. I have B and B prime, same thing. Okay, so let's look at an example with a coordinate point. Let's look at this coordinate point. Let's call it well, let's not call it anything. Where is it labeled? Let's say that it's at 5, 5. Okay. Let's flip it over the x-axis. Okay. This line is also known as x equals 0. Okay. If I take that and I want to, let's go and clone this. I want to flip it or reflect it over this. I'm basically going to be looking into my mirror. This is my mirror, and say, what comes out on the other side? If I were looking to a mirror, what comes out on the other side? Well, a dot comes out on the other side. But if it were an actual image, it would be flipped, much like this one. It would be something that's a flipped image, right? But the important thing is that the dot is the same distance away from the axis of symmetry as this dot was. So this point is 5, negative 5. I'll go and write it down. 5, I'm sorry. This point was 5, 5. This point right here is 5, negative 5. Oh, that didn't work. There we go. So, you're just plotting points here, and you end up saying, okay, it flips over the x-axis. This line, by the way, and you're going to have to know this for assignments or for the future, this is actually y equals 0. That means for every x value, 1, 2, 3, etc., y is equal to 0. So, for example, this would be y equals 4, a horizontal line going all the way across. Just make sure you keep that in mind. Okay, let's do a quick talk about translation. translation will be the easiest one to do when you're referring to anything that will be, I don't know, with images. So it's some sort of shift, some sort of slide. If I'm going to the left here, they're sliding, they're shifting, or maybe they're going downward or something, you know. So you have something like that you're looking at there. So some sort of shift or slide. Whoa, come on. Some sort of shift or slide, and you're not changing it at all. So when we're talking about reflection, you would flip something over. Remember, we saw here, you flip it. When we're doing a translation, we're just taking an image and just moving it. Okay, so let's do an example here. Let's have that same dot. And let me go and clone it again. Let's shift it 2 units down. Oh, well, yeah, sure. Let's shift this 2 units down. So let's just go and do that. 1, 2. And let's shift it 5 units to the right. 1, 2, 3, 4, 5. Okay? Now that is a translation. And let me even change the color of this. I should have done that with the other one. Let's make it red. The black dot for some reason. Okay, so this original point, this was 5, 5, right? Well, what's this new point? Well, we could count it off. We could say 1, 2, 3, 4, 5, etc. 6, 7, 8, 9, 10, 1, 2, 3. So we know the point's 10, 3. But what you'll end up seeing on your assignments is, let's make smaller this time. Let's say, okay, so this one was 5, 5, right? And this one we know is 10, 3. But what else did I say about it? Keep in mind that you might end up having problems where it'll be an actual image, and it might not say shift down 2 units and shift to the right. Shift to the right 5 units. Maybe it'll say, okay, we had an original X value and original Y value. Let's go ahead and change everything. Change every X value to X plus 5. And let's change every Y value to Y minus 2. So basically what I said here was, I'm going to shift everything that was an X to the right 5 units, and everything in the Y direction down 2 units. Keep in mind that negative. That's what that means. Okay, so that's what that shift is. So if I said, take this and make it, well, that didn't work. I'm still getting used to smartboard stuff. Make it X minus 10 and Y plus 2.5. Well, what's my new coordinate point? Well, do 5 minus 10, which is negative 5. And do 5 plus 2.5, which is 7.5. So my new point would be somewhere over here. 5, 6, 7, 7.5. So that's where my new point would be up there. Okay, so that's all a translation is. And eventually we'll do it with shapes as well. These are individual dots. Okay, and finally, let's look at rotation. Now, rotation is going to be the toughest to grasp because it's going to be so difficult to draw. And I'll try and do... it won't be so difficult to draw, but it'll take some real practice. And I'll try and do the best I can showing you with computer technology how you can best look at it, but then in the end you're going to have to kind of do it on your own here. So by rotation, you want to take a point and say that it's on a circle. So you see Napoleon Dynamite here. He's hitting a tetherball and he's hitting it in a circular path. So when you have a point, for instance, like a dot, you want to make sure that it stays on a circle. In other words, here's the circular path. You want to keep it on that, say, that radius from the center. And then always facing the center. That has to do with shapes, and I'll talk about that later. Okay, so we have our infamous point here. I want to do a rotation here. Let's say that there's a problem that says, I want to rotate this object 45 degrees counterclockwise about the origin. Okay, so that's a lot of words. So let me go and write it down here. Rotate position. Let's call it position 45 degrees counterclockwise. That's what the CCW means. About the origin. About just means that that's your fixated point, right? That's like your center. So let me go ahead and even put that down there. So there's my nice center point. It's nice and in red. Okay, here's what it means. I want to take this point and start going counterclockwise. Hopefully you know this way is counterclockwise. And I want to do it 45 degrees. So if you imagine like a circle, or if you can make angles of your own or whatever, what would 45 degrees be? Well, think, for instance, this is 90 degrees, right? This is 90 degrees, so 45 degrees would be half of this. So when I do 45 degrees, eventually I'm going to end up somewhere here.